My name is Rohit, and today I'll be giving a brief description of night vision technology and a brief description about its working. So, night vision technology, as everyone knows, it's almost impossible to see objects or, for that matter, anything in the dark. So, we do need means to access to know what are around us or the objects that are surrounding us during the dark when we are helpless. So, night vision is used to locate an object which is 200 yards away even in moonless and cloudy night. So the 200 yards is the maximum distance and maybe well within that range. So the night vision technology can be used in two different ways depending on the technology used. So there are two ways. One is image enhancement and the other is thermal imaging. So the image enhancement works by collecting the lower portion of the infrared light spectrum, while the thermal imaging operates by capturing the upper portion of the infrared light spectrum. So let's just see in this spectrum map, shall we? So this is the infrared portion of the spectrum right here. So this is split into half, which has, this one is the lower part of the infrared spectrum and this is the larger part of the infrared spectrum. The lower part is dealt by the image enhancement, while the larger part is, the bigger part is treated by the thermal imaging. We don't consider any of this visible and ultraviolet rays. It's for further reasons which you will see in the future slides. So now that we have understood the basics, let's go a little bit deep into the meaning and definition. So image enhancement. So what is image enhancement? A layman asks. This works by collecting the tiny amounts of light, including the lower portion of the infrared light spectrum, as I just showed you, that are present but may be imperceptible to our eyes, and amplifying it to the point that we can easily observe the image. So consider an example as a dark room. There are, you know that there are objects but you cannot clearly see them because light is not reflected of these objects into your eyes. So you need ways to know what objects are and where they are. So this image enhancement techniques is helpful for only those objects that are cold, in other words that do not emit any amount of heat. The thermal imaging, on the other hand, operates by capturing the upper portion of the infrared light spectrum, which is emitted as heat by objects instead of simply reflected as light. So this is used to detect a person in the dark room because he is the person who's emitting light. If it's a person or an animal or any body that emits light. So hotter objects such as warm bodies emit more of this light than cooler objects like trees or buildings. Suppose this might be something of high-tech stuff for a normal person. So this may seem like Greek and Latin for the people who do not know what the basic properties of light are. So let's just go through a little basics of the light properties. So in order to understand night vision, it is important to understand something about light. The amount of energy is related to its wavelength. So shorter the wavelength will have higher energies, the longer wavelengths will have lower energies. Since the UV rays and the visible light right here have the larger energy than the infrared rays, these are not suitable for the night vision devices because they are going to harm these devices, and hence infrared has been perfectly used. Right here you can see infrared has been used for these devices. So the infrared is categorized into three parts. The near infrared, which is right next to the visible light, which has low energy because it has slightly longer wavelength than the rest of the infrared rays. The next is the middle infrared rays, which is right here, which have more energy than the near infrared rays, and the far infrared rays, which cover the entire region up to the microwaves, have the most energy of the infrared ray spectrum. As we can see right here, the near infrared has 0.7 to 1.3 microns is the range of the near infrared rays. The mid infrared has 1.3 to 3 microns, and the far infrared covers the range from 3 microns to over 30 micron or until the microwaves range of the electromagnetic spectrum band is reached, which is like really big. So let's just have the working of thermal imaging. This is a normal scenario. Just consider a scenario. There is a cold object, which is a tree, and there is a hot object as a tank, or maybe a warm object with people inside. So what it does is this is going to emit photons as well as infrared rays, which is captured by the optics and focused by the optic sensors right here. So this is going to emit little less infrared rays, while this is going to emit little more infrared rays. That is where we distinguish between the cold and the hot objects right here. So this fiber optics concentrate all the photons and the infrared rays onto the infrared detector, which is connected to the fiber optics right here. So the infrared detector, what it does is it's going to convert all the photons into electrons and then back to image, which I'll be explaining it a little later. The infrared detector converts all these photons into a detailed temperature pattern called a thermogram. The thermogram is the output of the infrared detector. The thermogram is then converted into electrical impulses. These electrical impulses are the input to this signal processing device. The signal processing device has a dedicated chip that converts all these impulses to output that can be used as visualizing for the data, elements into data for the display. So this display can be done either using a standard video monitor as a TV, or a video recorder, or an ocular lens, which I'll be explaining a little later. So let's just go into the working principle of the basic, including the thermal imaging and the image enhancement process together. What is the working basic principle of a night vision device? So there are just two processes. The image is first scanned in the fiber optics. So this is nothing but scanning the environment beforehand, before conversion into the heat image. So this uses all the computer graphics knowledge that we have learned so far, which is like affine transformations, rotation, translation, scaling, and hidden surface removal. So let me just give a brief definition of what these are. So rotation, suppose if you have a tilted image, we need to get a straight image. For that we use rotation. Translation is from 1D, one-dimensional image to a two-dimensional image, from a two-dimensional image to a three-dimensional image. That is translation. Scaling, suppose we want to view a smaller object in a larger scale. So that is when we use scaling by mapping smaller coordinates to bigger coordinates. Hidden surface removal, suppose we have an object hidden behind another object and we need to view the object that is hidden, we use the hidden surface removal. The next step is the signal processing. Here the image in 2D form and the graph is supplied as inputs, based on which a proper output is placed on paper. The graph supplied as inputs here is nothing but a graph of the electrical impulses and the thermograph, as I explained in the thermal imaging, are these graphs which are supplied as inputs, and the proper output on the paper is the final heat image that has been delivered by the night vision device. So here is a small pseudocode for the image enhancement technique. Yes, so this image enhancement deals with conversion of 3D environment into an intermediary grayscale image. The environment, the input is obviously the environment, the sensors and the infrared sensors. The output is a set of graphs and an intermediary grayscale image. So what we basically do, how do we begin, is we scan the environment using the night goggles. The night goggles scans each pixel. For each pixel in the scan image, we determine the temperature. After we determine the temperature, we determine the color density and the image conversion capabilities. Then we plot a graph for each of these quantities that we have determined in this stage, as a gradient of time, and that yields us our graphs for the next slide. Then we've pinned an image. This image is nothing but an intermediary grayscale image. Next is the pseudocode for thermal imaging. As we saw before, we got an intermediary grayscale image and a set of graphs. So we use this to get a heat image via this following code. So for each pixel in the intermediary grayscale image that we have got, and for each corresponding pixel in the graph, we interpolate the color as per the graph onto the grayscale image. This means that suppose there is a pixel that has a peak intensity in the thermograph and the electric impulse graph, then that must be mapped according to the intensity on the grayscale pixel. So this is done for each of the pixels on the grayscale image until all the pixels are finished. Next, we interpolate edges so as to get a blend or a smooth gradient of colors so that we shouldn't have any distortion. For this, finally we print a heat image right here. Yes. Right here we can see three scenarios. The first scenario is, you can see that it is bright. This is for an external person who is viewing the same scenario in three different environments. So the first environment, it is bright. You can see the trees, the car, the person running right here. It's all because of the light reflected of all these objects into the viewer. Here we cannot see anything because it's dark, and at the same time there is no light reflecting of any of these objects into the viewer. A person who wishes to see this at night can use these night goggles to get a totally different image, and he sees in total darkness. So right here you can see the trees, the mountain, the car, and the person running right here. Though it may not be as clear as in the bright, but yet the person, the viewer who's seeing this environment can get a clear idea as to where the objects are in the environment. Now let's come to the types of thermal imaging devices. So there are two types, uncooled and cryogenically cooled. So what are uncooled thermal imaging devices? An uncooled infrared camera is one which the imaging sensor does not require cryogenic cooling. A common detector design is based on the microbolometer, a tiny vanadium oxide resistor with a large temperature coefficient on a silicon element with large surface area, low heat capacity, and good thermal insulation. Changes in scene temperature cause changes in the bolometer temperature, which are converted to electrical signals and later processed into an image. Uncooled sensors are designed to work in the long wave infrared or LWIR band from 17 to 14 microns in wavelength, where terrestrial temperature targets emit most of their infrared energy. So this is the cryogenically cooled thermal imaging device is nothing but the opposite of the uncooled device. So now that you know what a thermal imaging process is, now let's view the image enhancement process. So here we have a night goggle, the night goggles or the night camera which we use to get this image right here. The normal camera won't give such a clear image because it's not it's not fitted with night vision. It's not a night vision device. So what it does is it transmits all the photons onto a photon plate, a photon cathode right here. The photon cathode later converts these photons into electrons and transmits them to the microchannel plate right here. The microchannel plate, it's nothing but it amplifies the electrons by converting all the atoms in the atmosphere in the tube into electrons, and then focuses the same thing on a third plate right here, the phosphor. The phosphor is mostly green in color, and hence these electrons are while converting into photons get a green tinge, and hence we get a green image right here. This full thing, the three plates right here, are enclosed in a tube as you can see here, the three plates, the photocathode, the photocathode, the photocathode, and these are the microchannel plates right here. The microchannel plates are right here. As you can see, the microchannel plates are right here. So this full thing is powered by the AA batteries that supply up to 5000 volts of electricity. That is more than enough to handle all the functionalities of all the components in the tube right here. So this is what I was exactly saying. A conventional lens captures the ambient light and some near infrared light. The two AA batteries supply about 5000 volts to manage the image tube components. The image intensifier has a photocathode that converts photons into electrons. The electrons pass through the tube, multiplying the original number through the microchannel plate. So this is the most important plate right here. At the end, the image intensifier tube, the electrons hit the coated with phosphors. A green phosphor image is viewed, which can be viewed either using an ocular lens or using a monitor, as in the same case as thermal imaging. So now let's take one example as night glasses. So what is a night glass? Night glasses are telescopes or binoculars with a large diameter objective, which means that you can view large areas by using this night glasses. Large lenses can gather and concentrate light, thus intensifying light with purely optical means and enabling the user to see better in the dark than with the naked eye alone, which means that the night glasses are really huge so that they can concentrate on wider areas and get intensified light by optical means and enabling them to see in the dark. So during the war era, the night glasses were usually 5.5 meters or 5.5 centimeters or more with magnification of 7 or 8. That means that they were really heavy and their size was huge because of the magnification and the diameter of the lenses. Now let's see two of the equipments which are right here. This is night goggles which I explained recently, and this is the infrared sensor. The night vision goggles right here has a photocathode which converts the photons into the electrons. The electrons have a microcontroller plate right here that magnifies the electrons and then goes to a final phosphor cathode which converts back the multitude of electrons into the photons and then gives a clear green image which you can view through these binoculars right here. So this is not a normal binocular, it is a night vision device. The infrared sensor right here is just used to capture the heat that is emitted in the environment that it has been placed on. Technical characteristics of night vision. So why do we need a night vision? If I say a layman, why do I need a night vision? So it's because we can distinguish between the light and the dark textures. So obviously the person in the night who's not visible, if he emits light, it's going to have a dark texture because he is the one who's emitting light, and the emitted light has more energy. And according to the mapping, as we have seen before, from the graphs to the grayscale image, the dark image has more intense marking there. The light image or the cold objects, for example like trees and mountains, they do not have as much heat emission and hence will have a lower intensity peak. Depth perception. So depth perception is nothing but we can know how deep the image is, or in the sense the clarity, or you can say the zoom, or you can say the magnification. The depth perception deals with all this. Fog and rain. So this does not affect any of the night vision devices. This is because even though there is a fog, it doesn't matter because it depends basically on the heat that is percepted in the surroundings, and neither the rain, because that also does not affect. Honeycomb. Suppose there is a honeycomb maze which you might have seen if there is a honeycomb maze, you are covered on all the 5 sides, and you want to see what is on the other side of the wall. You can see because the honeycomb is really thin. Suppose if it is a brick wall, then it is not possible. If it is a honeycomb, it is possible because the walls are thin, and the night vision devices are basically on the heat sensing devices, so they can easily know what is there on the other side of the honeycomb wall. Spots are basically used to detect any hot spots on the surface of the sun. Suppose if there are certain spots that have a higher temperature than the normal on the surface of the sun, and hence to detect those spots you can use the night vision technology right here. Applications. So these night vision devices have a variety of applications, and mostly they are related to security, surveillance, military, and all that. So military, so we obviously need means to protect our country in the night. So this military uses, what we do is they use the night vision devices to see if there are enemies approaching the safe territory, so that they can take action well beforehand. Law enforcement. Suppose the territory has been encroached, you can use the night vision technology to see the enemies in the encroached property and then take appropriate actions. Hunting. The hunters during day, if they are not satisfied, if they want to go killing even in the night, they can use these night vision devices, which is not suggested. They use the night vision technologies, they can hunt at night too. Wildlife observation is used for a tourism. So the tourism, certain wild animals come only at night because they are all nocturnal. If the tourists want to see such animals, they can use this night vision goggles and get to know an approximate image of the animal which they came to see. Surveillance is at the borders to capture any heat action that is going on outside the borders, if there is a threat to the natives right there. Security comes along with surveillance and military. Navigation, suppose if we are in a dark area and there is no lights, the lights are gone, and we need to know our way through that dark thick forest. So we can use this night vision technology to find our way through the trees because they emit heat. You can know that there is a tree right there, you can avoid it and then go. Hidden object detection is usually used for the mines and the bombs that are placed. That's because they emit heat when they are triggered, and the night vision goggle captures this heat and then sends an alarm immediately to the soldiers right there, who then go and defuse it. Entertainment comes along with the games right there. Advantages. Obviously this has several advantages, but I'm just going to list a few right here. So the main advantage is distance vision is possible. You cannot view, even though if you cannot view normally the far sighted, because there are goggles, night vision goggles, you can see distance vision. Detection of objects in absolute darkness is the most important advantage of this invention of night vision technology. It helps people to be safe even though you cannot see anything in the dark, and it's less affected by temperature variation, because even though the person moves, his temperature will emit the same, so less affected by temperature variation. So let's just give a conclusion, a strong point. Night vision is used to locate an object which is 200 yards away even in moonless and cloudy night. The original purpose was to locate enemy targets at night, which was basically invented during the World War I and the World War II. It is mainly used in military purposes as well as navigation, surveillance and targeting. So basically the night vision devices is used for security and for night vision, for distance vision. So thank you for listening to my presentation. Have a nice day.